Something unprecedented is happening above us tonight. For the first time in history, an interstellar comet has been placed under a United Nations planetary defense exercise, an activation normally reserved for complex impact risk objects, not something scientists publicly insist harmless. The UN's International Asteroid Warning Network has quietly launched an observation campaign stretching from November 27, 2025 to January 27, 2026, pulling in telescopes from every continent, space-based observatories, and even instruments orbiting Mars. And all of this is focused on one visitor, 3I Atlas. Officials say it's routine, but the scale says otherwise. Because the moment the exercise was announced, astronomers and amateurs across the world noticed something strange. The timeline didn't match NASA's calm explanations. If this object is behaving normally, why mobilize a monitoring level usually triggered by uncertain trajectories or unpredictable behavior? Why activate coordination servers, emergency scheduling channels, and joint data relays for a comet that is supposedly no threat? Nobody will say it out loud, but the timing hints at one thing. 3 Atlas has shown behavior that is no longer easy to file under ordinary. And the newest images only deepen the mystery. Over the past week, frames have dropped from Spain, Thailand, Norway, Virginia, and several backyard telescopes, each capturing something that refuses to fit the textbook definition of a natural interstellar comet. In Spain, a long-exposure image taken on November 22 revealed a coma that was shockingly stable. Even with background star streaking, the core remained tight, clean, and perfectly circular. If this object were fragmenting or shedding material unevenly, the inner brightness peak would wobble or distort. Instead, the energy distribution is almost mathematically precise, too precise for something driven by chaotic sublimation. Then Thailand's observation arrived. Heavy cloud cover, low transparency, and yet the brightness profile looked nearly identical to Spain's data. When enhanced, the central glow formed a near-perfect ring surrounded by layered halos that almost resembled stacked shells. Comets don't normally make symmetrical halos like that unless something is guiding the outgassing in a very stable pattern. Hours later, Norway contributed its frame, and this one caused the biggest stir. From a Bortle 4 sky with barely an hour of exposure, the tail came out razor clear. A faint curl was visible along its outer edge, as if the material wasn't just flowing outward, but twisting, spiraling, like it was responding to rotation or an internal structure distributing mass in a controlled manner. Rotation alone doesn't create a tail this organized. Something about the flow looked patterned. One detail began to stand out. Spain showed a perfect core. Thailand showed symmetric halos. Norway showed a curling, rotating tail. 3 countries, 3 conditions, 3 instruments, 1 behavior, a stable center rotating emission, and a halo expanding faster than projections predicted. And then came the wide-field Virginia shot capturing something almost no one expected. A faint extended tail stretching far beyond earlier exposures. Long, thin, structured, not a chaotic plume, but a coherent stream maintaining its definition even in low-sensitivity regions of the frame. With every new data point, the core remains perfectly circular. Comets with asymmetric activity don't do that. The symmetry should break first. But here, the symmetry is getting stronger. This is what pushed some astronomers to quietly admit there is something about 3I Atlas that is not matching natural expectations. And this is exactly when the UN exercise was activated. Inside observatories, schedules were rewritten. Telescopes were reoriented. Deep sky surveys paused as teams shifted to high-cadence astrometry trying to pinpoint the comet's center through its bright veil. That alone is difficult. A diffuse coma hides the nucleus, but 3 Atlas makes it even harder. Its jets appear stable across long exposures, barely rotating, days apart, same position, same angle, same strength. That simply isn't normal. Interstellar comets should behave even more chaotically than solar system ones, not less. They carry volatile ices, undergo unpredictable heating, and often show erratic rotation. But 3I Atlas carries a pattern, a rhythm, as if something internal is restricting its rotation or maintaining fixed vents. Infrared readings only added fuel to the mystery. Its coma shows an unusually high CO2 ratio, far above the levels seen in most long-period comets. That suggests a formative environment very different from our solar system. Maybe colder, maybe chemically skewed, maybe shaped by conditions we haven't observed before. But even then, the consistency of the jets challenges simple explanations. They don't fan out. They don't swing with rotation. They hold their direction. Some scientists suggested extremely slow rotation. Others suggested vents locked into a fixed orientation, but many quietly acknowledged neither fully fits. At the same time, brightness spikes began appearing in amateur data. Small, fast, unpredictable increases that didn't show up in NASA's smooth light curves. These weren't dramatic outbursts, just subtle pulses that overlapped suspiciously well with changes in the halo thickness observed across global frames. When amateurs compared notes, a pattern emerged. The comet brightens slightly, then the outer shell expands, then the tail sharpens, but the core stays unchanged. It's behaving like a stable engine surrounded by unstable vapor. For many, this is simply the signature of an interstellar comet with unusual chemistry. But for others, especially those analyzing the astrometric deviations, it hinted at non-gravitational forces that didn't match the expected profile of a venting nucleus. The object seems to be experiencing slight persistent accelerations. Not huge, not alarming, but not random either. That is exactly the sort of complexity the UN's planetary defense drill is designed to test. But here is where the tension rises. AWN denies any emergency. NASA says everything is behaving normally. The European Space Agency echoes the same. Meanwhile, the coordination channels are buzzing. Tracking assets at Mars have joined in. Some observatories received private notices. Global observation density has tripled. And nearly all data processing servers are running at full load. Officials say this is just practice, and maybe it is, but the public has never seen an interstellar comet put under a structured months-long planetary defense campaign, especially not one whose behavior is becoming more unusual with every passing night. The truth may be simple. 3 Atlas is natural but strange, a visitor unlike any we've documented before. If so, this is a rare chance for humanity to refine its planetary defense capabilities on something unpredictable, exotic, and scientifically precious. But the other possibility lingers in the minds of observers. Maybe there are still features we haven't fully understood yet. Maybe there are anomalies officials want confirmed before saying anything definitive. Maybe the object's extraordinary symmetry, stable jets, chemical makeup, and slight accelerations demand a level of precision the world has never practiced before. Whatever the truth is, one fact remains undeniable. 3I Atlas is now the most closely watched interstellar object in human history. Not because it is a threat, but because it is an anomaly, a traveler from the deep passing through our system with behaviors that challenge assumptions and push our detection network to its limits. The next weeks, as the observation exercise intensifies, will reveal whether the mystery deepens or dissolves into clearer science. Either way, the world is watching because objects like this don't appear often. And when they do, they change what we think we know.